Okay, so for the example letter A, we're going to add vector A plus vector B, and let's try to add it graphically. So for the vector A, we have 12 units at 30 degree, and so let me represent it with my ruler, wherein my representation for my ruler, that is, for every 1 centimeter of my ruler here, I'm gonna have 2 units. And so for vector A, that is from 12 units, and for every 2 units, that is 1 centimeter. So it will gonna be represented by 12 divided by 2, that is 6 centimeter. And for my vector B, that would be 8 units times 1 centimeter, and that is 2 units, and so that would gonna be represented 4 centimeter on my ruler. So let me graph first the vector A. So the vector A now, that would be 6 centimeter at 30 degrees. So I'm going to plot here. So I'm gonna have it on 30 degrees. Okay, and then afterwards I'm gonna have it 6 centimeter. So 1, 2, 3, 4, 5, and 6. So that would be my vector A. Now how about the vector B? Now for the vector B, that would be 4 centimeter at 80 degrees. So here I'm gonna use the head to tail method. So 80 degree, I'll position it at 80 degree. So if you have your protractor, you could have your protractor here. So it's around 80 degree. So I'm gonna have 4 centimeter, 1, 2, 3, and 4. So this one will be my vector B. And so let me now get my resultant vector. So the resultant vector now is somehow like this. Okay. So let me count it first. So that is 1, 2, 3, 4, 5, 6, 7, 8, and 9. So somehow here, the resultant vector, which is the vector A plus the vector B, that is around 9 centimeter. And if I'm going to express it in units, that is for every 1 centimeter, I have 2 units, and therefore my vector here it's 9 times 2, that would be 18 units. Now what is the angle? If I'm going to measure the angle, let me just validate the angle here. So the angle is around 50 degrees. So the angle at 50 degrees. So meaning to say, in our case of vector A plus vector B, the sum of that is 18 units at 50 degrees. Now let's try to have our second case, which is vector A minus vector B, and we're going to represent that with 1 centimeter equals 2 units. So let me start again with the vector A, which is from 12 units, that is again divided by 2, and that is 1 centimeter. And so I will gonna represent that with 12 divided by 2, that is 6 centimeter on my ruler. Now for the vector B, so 6 centimeter at 30 degrees. Next, that would gonna be 8 units for the vector B, that is 1 centimeter and 2 units, and therefore I will represent it with 4 centimeter, and we have here at 80 degrees. Now since that is minus B, that would be plus 180, but still if it is in your ruler or protractor, that would be 80 degrees, but you're gonna change the direction, so that is 80 degrees anti-parallel. And anti-parallel, the concept of anti-parallel, that is 80 plus 180 degrees, and that is around 260 degrees. So let me just show it first on how to graph it. First, I'm gonna get my ruler again, 6 centimeter at 30 degree. So make sure that our ruler is 30 degree. You can use your protractor here. So I'm gonna have 6 centimeter. I represent my vector A with this green color. So 1, 2, 3, 4, 5, 6. Somewhere here. Next, we have 8 units for the vector B, which is 4 centimeter. So I will plot 80 degrees. So this is my 80 degrees. Okay, now instead of plotting it like going here, okay, I'm gonna plot it with an anti-parallel, which is 80 degree, because that is minus, and so that would be 1, 2, 3, and 4. And so this now is my resultant vector. By the way, this is my vector A, and then this is my vector B. And so what is now my resultant vector? Let's try to count it. Okay, there you have. So if we're going to count it, that's around 1, 2, 3, 4, and 0.5. So this is my resultant vector. That is around 14, not really, that would be around 4.5 centimeter. Now let's try to calculate here. The resultant vector, which is vector A minus the vector B, that would be 4.5 centimeter. And again, for every 1 centimeter, that would be 2 units, and 4.5 times 2, that will gonna be 9 units of the vector. And what is the angle here? Let's try to look at the angle. Let's try to approximate. So that's around 13 degrees. So that is around 13 degrees. And so this is the answer. The resultant vector for A minus B, that would be 9 units and approximately at 13 degrees. 13 degrees what? 13 degrees below horizontal. So this time, let's try to represent the case of letter C, which is A minus 2B. Now, for the case of A minus 2B, we have here for the vector A, that is still 6 centimeter at 30 degrees, simply because 1 centimeter equals to 2 units, and if it is like 8 units, that is 1 centimeter over 2 units, and that is 4 centimeter at 80 degrees. Now, if we were going to represent negative 2B as our vector, that would be 16 units, and the counterpart of that 16 units, that would be also 8 centimeter at 80 degrees anti-parallel. So meaning to say opposite in direction. And let's try to see if it is like anti-parallel, that is 80 plus 180, that is around 260 degrees. Now, let's try to sketch now vector A. Again, I'll get my ruler. Vector A is 30 degrees. And then we're gonna have 6 centimeter. So we have 1, 2, 3, 4, 5, and 6. So this is the vector A. Next, vector B, 4 centimeter at 80 degrees. Okay, there you have, that is 80 degrees. And then instead of 4 centimeter, I'm gonna write 8 centimeters. So 1, 2, 3, 4, 5, 6, 7, and 8. So this will be the vector negative 2b. And then let's try to get now the resultant vector. So that is around, let's see. Let's see here. So if I'm going to measure it, oops, it's around 1, 2, 3, 4, 5, and 6. So that is around 6.1 centimeter. So the resultant vector, that is 6.1 centimeter. So let's try to convert this 6.1 centimeter. 6.1 centimeter times, for every 1 centimeter, I'm gonna have 2 units, and 6.1 times 2 units, that will be around 12.2 units. And so this is the representation of our vector. This is the magnitude of vector A minus twice the vector B. And at what angle? So let's try to look at what angle. So if I'm going to position my ruler here, that is around uh, 50 degrees. So that is around 51 degrees, I think. Okay. So meaning to say that is at 51 degrees below horizontal. And so that's it. This is the representation of my vector A minus twice of the vector B. Now let's try to answer number 37, wherein this time we have to repeat the previous problem using the analytical method or the components. So first, for the vector A, we're gonna have 12 units at 30 degree, and so we're gonna get the x component as well as the y component. And also for the vector B, which is 8 units at 80 degree. Now, how are we going to solve for the x component? For the x component, that is simply cosine of 30 degrees times 12 units and that is 13.39, 10.39 rather. Next, for the y component, that would be sine of 30 degrees times 12, and that is 6. And next, for the bx component, that would be cosine of 80 degrees times 8 units, and that is 1.389. And the y component, that would be sine of 80 degrees times 8 units, and that is around 7.878. And so what we can have it here right now is we're gonna get the summation of x, and that is 11.799. And for the summation of y, that would be 13.878. Next, we're gonna solve that analytically. That is the square root of the summation of x square plus summation of y square. So we're gonna get now the resultant vector, and so that is the vector A plus the vector B. That would be the square root of 11.799 square plus 13.878 square. So just press it in your calculator, and what would be the answer here? That would be 18.2. So this is around 18.2 units. And let's try to double check. This one is 18 units, and so this one is 18.2 units. And next, how about the angle? So remember that that would be arctan of summation of y over summation of x. And that is the arctan of 13.878 over 11.799. And so the angle would be 49.6 degrees. So let's try to see. So somehow that is also equivalent to 50 degree. So analytically, we're gonna get a more precise answer, which is 18.2 units at 49.6 degrees. Now, this time, how about for the case number letter B, which is A minus B. And so how we're gonna change our equation wherein we're gonna have A minus B. So the first thing that we're gonna notice here, so we have a negative B. And so a negative vector B, it is an anti-parallel. So it changed the direction of the cosine function for the 80 degree and the sine function of 80 degree. In fact, if we're gonna have it as negative B, that would be cosine, and then this one of 80 degree. But if you're gonna press for an anti-parallel, this one will become negative, and then this one will also become negative. But if you try to observe, the angle is 80 degree, and so if the angle is 80 degrees for a negative B, so that would be 80 degrees plus 180, because we're gonna flip it in an anti-parallel, and that would be equal to 260 degrees. So I will change this with 260 degrees, and I'm gonna change this with 260 degrees. And if you're gonna press that in your calculator, again, I would emphasize that there will be a negative values here. So the summation of our x will be now different, and the summation of y. So the summation of x here, that would be 9.001, and for the summation of y, that would be negative 1.878. Changing now these values, this one is 9.001 square, and that is negative 1.878 square. And so the final answer here, that would be, if you're gonna press that in your calculator, that would be 9.19. And so checking for the values of our graph, that is around 9 units. And what is now the angle? Let me just erase this. And the angle now would be, that is negative 1.878 over 9.001. And so the angle here is that is negative 11.8. Below the horizontal. So I may write here at 13 degrees, but I think it's more on the errors regarding the exact or the preciseness of my graphical way or graphical method, and that is negative 11.8 degrees. Now take note, that is negative 11.8 degrees below horizontal. 11.8 degrees. Now let's move on to our next concept, which is we're going to represent it with a minus 2b. And what will be changed on our solution? So again, that would be still an anti-parallel for the b. That is still 260 degree, but we have to multiply the x component and the y component by 2, or this one is 2 times 8. This one is 2 times 8, or I could say that would be 16. So that would be 16 here, and the other one would be 16. And so what will gonna be changed? It will already change the value here, and so that would become 7.612, or from here we're gonna have cosine of 260 times 16. So that is 2 times 1.398. That would be 2.796. And next here, that is 2 times 7.878. That would be 15.756. Oh, by the way, it's negative. By the way, that is negative. So let's just press again the calculator. So cosine of 260 degrees times 16, and that would be negative 2.796. And then the other one would be sine of 260 times 16. That would be negative 15.756. Okay, so what will gonna happen now with the summation of x and the summation of y? This one will gonna be changed, and so adding that will become 7.612, and then this one will become negative 9.756. So let's change this value. Change this value also, and we're going to change this value and change this value. And so this one we're going to be 7.612 square negative 9.756 square, and the result would be 12.4. So not bad. So this one will become 12.4 units, and if you'll try to see on our graph, the graph says it's 12.2 units. And how about now for the angle? That is negative 9.756 and then 7.612, and that is around negative, the arctan of that, if you're gonna press that in your calculator, that would be negative 52 degrees below horizontal. So somehow in our graphical method, that is 51 degree below horizontal. So this is still not bad for the graphical and analytical results.